Hello guys, welcome back to my channel. Today we are going to be looking at a G+1 residential story building, and in this video I'm going to be teaching you guys how to create a structural layout for this type of drawings. I'll also be explaining the design principles I use behind my decisions while making structural layouts. So let's get to it. So first things first, we look at our architectural drawings. You can use any version of AutoCAD to view your architectural drawings. So in a G+1 story building, we are expecting to see the ground floor and first story. As we can see here, the ground floor plan and the first story. We're going to make a copy of the original architectural drawing. The reason why we're making a copy is because if we are working on the drawing and working on the original, if there's a mistake, we have to revert back to the original drawing. We have to call the architect, which is unprofessional. So it's best you make a copy. To make a copy, you have to highlight the drawings, right click, and select copy section. If you can select copy section, you pick a base point, any point, and paste anywhere you want. You have another option to highlight. Yes. Then type CO, which is the shortcut for copy on your keyboard. Press enter and you pick any base point you want. Then paste anywhere you want. So the same thing. So now that we have made the copy of the architectural plan, the next thing we need to do that is very important is that we have to study the architectural plan. So what do you mean by study? We need to understand the pattern of movement with people within structure. So for that, I want to use this because you can see, if you look closely, I've already removed all the write-ups on the plans here. So let's look at this. This is the ground floor. So if someone is entering inside this building, it's going to enter through the entrance door here. It's going to be faced with the ante room or the waiting room, the visitor's toilet here. You can enter the main parlor through this door here, and you can, by looking straight forward here, you can see that this is going to be able to see the dining area here. Then if you go by his right, you can see the laundry. Keeps going straight. You can enter inside the bedroom, where you also have access to a toilet. You can see a wardrobe here. This X here signifies a void. This staircase here on your structure layout is also going to be a void because there's not going to be any slab there. It's a void. So if we zoom out, you can continue. From the dining area, you can access the kitchen. From the kitchen, you can see the balcony here or the store. Going back to the staircase, you climb, you reach upstairs. As you reach upstairs, you come out through here, you can access the master's bedroom. Then you can access the balcony from here too. You come out. There's a walk-in closet around here. There's a toilet close to the walk-in closet. So if you come out from, if the person comes out from there, you can see that there's a home office here. You can use the family area. All I'm trying to say is by understanding the movements of a person in the structure, it means that there's not going to be movement outside anywhere you have analyzed. The four corners of this building, there's not going to be movement anywhere. Nobody's going to pass through any wall, nothing, because we already know where all the walls and all the openings are. So that's all I'm trying to say. Also, we have to take a look out for the cantilevers here. You can see that this is the ground floor, the first floor. If we look closely, we can see that this here is going to be a cantilever. And the cantilever now could be a cantilever slab. Then since you can see here, there's surely going to be a slab. Then the roof beams surely cantilever out. So so if you understand that, we're good to go. After we understand this drawing, as I said before, it means that there's not going to be any movement outside anywhere that we have analyzed. Let's start work. We'll go back to the architectural plan that we have copied out and look at it. We're going to remove everything we don't need in a structural layout. And so we're going to make our own grid lines. You can just right click after select similar. In order to make sure that another drawing is not being selected, you zoom out, look at many drawings. Then if there's a selection outside of what you intend to select, you hold down your shift key and highlight it. So something like this now. You can see it's gone. Then we can press delete and you can see everything now. Okay. So I purposely left the doors here and the windows. I like leaving them so that if I'm doing a column placement and my column is on a window, it can be moved without shifting the window. I always encourage that to keep the aesthetics of the buildings, work hand in hand with the architect. So let's go. So we move on to grade. The grade, what I like to do, I will use a line and to draw across this block wall here, because okay, escape, one line, can press L, enter to run a line here. Drop it. Okay. So my grid line will now be at the middle of this line here that it does through here. That's what my grid line is going to be. So okay. The dimension for my block wall. So I'll pick the dimension 2. Come here and measure 225. So my block wall is 225 millimeters. So I'll keep that in mind for my column size. 9. So you press Excel, enter. You choose whether the extended line, because it's going to extend around the full workspace, is going to be horizontal or vertical. I want to start with the horizontal, so I'll press H after pressing Excel. Now that line that I drew, I'll look for the center and I'll put it. I'll press Escape, XL, enter. I'll press V, enter for vertical. Then put it. So now from here I can copy this and paste it around every intersection of the block wall. Or if you have time, you can do it one by one. I want to copy. So copy selection. You need to pick a base point. Let me use here. Okay, I don't think I copied it well. Copy, I want to start with here. Select, copy selection, pick a base point. Okay, so now I'm placing it at every intersection for block walls. So that's where. So this is the first step of creating your grid. Always keep that in mind. Okay. So okay, I'm done with all the verticals. Let me switch to the horizontals. So I said pick a base point I want to use here. Come back here. Okay. Remember, there's no harm in zooming in. Make sure you get the exact points. Copy. keep putting just okay. So our both done horizontal and vertical. You can see the lines are extending beyond over your whole workspace. So to trim the lines, we're going to run a rectangle around our drawing. The size is based on your own discretion. Then I'm going to select the rectangle. I'm going to choose trim. You can select the rectangle and press TR on your keyboard. And delete this, delete this, delete this. So you can see that. Delete. So we have our grid lines. Okay. So I want to use a layer to identify my grid lines. So what I'm going to do is, let's see, stay layer for my grid here. Now I'll create a new layer for each step. And now select layer properties, choose your new layer, then name this one grid. Okay, I think that'll be okay. I'll click anywhere. Then select this, select similar. Okay, can close this. Remember, look at your drawings and deselect. Okay. Okay, so we can now assign them to the grid layer that we just made. So everything here is under the grid layer. This is going to really help when we move it down to ProtaStructure. It's 1, 1, 2. Okay. So after we've created our grid, we have to create our columns. Remember, our block hole size was 235 millimeters. So that is going to be our sizing. So we use the line function. You can select there, or you press L, enter. You draw 225, enter. 225, enter. 225, enter. 225, enter. Excuse me. Okay. So now select this. We can assign it a layer. I think I should have already. Have a layer here for 8 columns. Yeah. Okay. So then we can now join them. Okay. So that they can be one. Okay. Then hatch inside. Use the hatch function. You can click this or type hatch on your keyboard. Anyone. I want a solid hatch. I'm using the color red. I like my columns red. Okay. I can do this. Then I'm going to pause this video so that it won't be too long, and I'll put the columns then I'll pause it and we'll talk after that. Okay guys, I've finished placing my columns at the intersection of every grid line. If you look closely, you can see that there's a problem here. This design is uneconomical. I've carried this as our column layouts. Why am I saying this? You can see that the columns are clustered together and there is no proper spacing. To solve this, we have to look at the first rule when I'm doing my column layouts is we have to take note that the distance between the two columns would surely be the length of the beam. So when you are spacing your columns, it's advisable to keep it below 6 meters or 6 meters, because the more load on the beam, the longer the beam is going to have deeper depth. Assuming a depth of 450, we're using a depth of 450, that's 25 by 450, there's likely going to be a failure. So keeping it within 6 meters is safe. It does not mean that we cannot design a beam more than 6 meters, but as I said, the longer the beam, the longer the depth. Okay, so If we look at this now, we'll use our dimensioning tool to take the distance. Okay, I want to take distance from here to here and extend it out. It simply means that we don't need this column here. So this column can go. And to also measure from here to here. If I take it out, you can see that it's 3.715, meaning that we don't also need this column here. If I measure from here straight down here, you can see that 5.6. You don't need these two columns here. Delete. Delete. I'm thinking of you turning here to one panel, and the panel is the slab, assuming a depth of 450 millimeters. It is 150 for the slab and 300 for the beam. So if we're using a depth of 150 millimeters, it's advisable to keep it within an area of 30 square meters. Anything exceeding that might lead you to increase the depth to around 175 or 200 or even more. So I'm going to remove all this. It's going to be one panel. Let's remove the store. You can see that this column here is not necessary at all. It's not necessary. But here, if we measure from here to here, so I want to make this one panel. I want to make this another panel. And I want to turn this to one panel. So let's see how it goes. This like this, I want to make it one panel. So you can see that from here to here like this, if we multiply and bring on my calculator, sorry, quick calc, yeah. So if we multiply 5.632 by 4.903, what do we get? 27.61, approximately 28, and it's not up to 30 square meters, so we can still go with this. So you can see that other panels are smaller, so we're safe. This is the biggest panel, it's not up to 30 square meters. So let's go on I want to convert this whole place to one panel. I'll be able to close here off as one panel. Here one panel, here one panel. I want to close here off as one panel. So this column is going. Guys, don't forget to like, subscribe, drop your comments. If you have any questions, I'll get back to you. This is going to be the primary beam, while this one coming up here will be a secondary beam acting as a point load on this primary beam. That's what we're going to do here. Skip. Coming down. So we have here, panel 1, panel 2, panel 3. So if we keep going, I can turn here to one full panel. Turn here. Like this. Okay, let's look at this now. So if you're accessing this staircase and you're climbing up, like you hit the first before the final landing. So if you climb like this, there's going to be a slab above your head. When you reach here, it's going to be empty. So this panel we want to make run from here like this and here like this to form one full panel, one full slab here. Okay. And if we check, it's not still going to be up to 30 square meters. So we're still safe to go. This column will surely go. So we have 1, 2, 3. Let's see. We don't need this column here. We don't need it. So it can actually go. Too much. So you can see we have panel 1, panel 2, panel 3, panel 4. You can close this off as one panel. Let's check. It's 5 by 5.23. From center to center, 4.9 is going to reach. It's not up to 30 square meters, so we can go ahead and turn this to a panel. So we have another panel here. panel 1, panel 2, panel 3, panel 4, panel 5. So we can turn this now to a panel here. And to offset the line. So I have this. So remember what I said, that these panels we're seeing is where it's going to carry the story 1. So you can see now we have done the column placements. We have placed our beams and our panels. The column placements, we have used the principle that it should be within 6 meters. And the slabs we have also used the principle that we should try and limit it to an area of 30 square meters. It's not that the panels, the slabs, that we cannot design a panel that is above 30 square meters. It only implies that the regular thickness of 150 millimeters will need to be increased, and the self-weights and other forces acting on top of the slab would lead to punching, whereas we have to use the principle of flat slab to tackle the joints. So to avoid all that is the reason why we're using the 30 square meters rule that I told you guys about. Okay, so as you can see now, we have formed the general arrangement for this now. So this is the general arrangement for the first floor. This is what is going to be carrying the first floor. Okay, so now what we have to do is to superimpose the grid and column placement from the general arrangement done on the ground floor to the architectural plan done on the first floor. This would help us to know if there's any column that is coming out of the wall that is in a pathway or blocking, whether we can stop it and initiate a floating column to continue. So let's check. Select this. It selects the columns. Use the command select similar. Look out if there's any other drawing that has been selected. Okay, so we're good to go now. So we'll pick a base point. While picking a base point, I advise that you pick a staircase because it's one of these is stationary in the structure. There's not going to be any change in the staircase. So copy, pick here, tossing, and place it. So that's it now. Remember, we talked about these cantilevers that are here. So I've already taken note that there's going to be a cantilever. Okay, so I've superimposed this now. What we can see is all the columns are aligned with the walls. So you can see all the columns are aligned with the walls around here. Everything is okay. Okay, we have an issue here, around here. You can see this column is inside this room here. So what we're going to do is we're going to move this. This column is going to stop here and it's going to start around here. So we're going to initiate the floating column. The beam here will carry this column from here, and this one will stop here. Then this one will stop here and shift, and it's going to start around here. So that's what we're going to do. So copy, okay. So we can use this to signify that the column is going to stop here. Okay, so that's what we're going to do. So you get what I'm saying? So this column is going to the roof. This column is going to the roof while the stopping here is stopping here. That is simply what I'm trying to say. So there's a cantilever here, cantilever this slab here, cantilever here, slab, cantilever slab here. We can span a beam towards here, cantilever it out. We'll span a beam towards here, cantilever it out. Whereas it will carry a beam that will run in here, then we'll put a slab here. So the next thing we have to do now is to turn this our ground floor GA to a block. To do this, you will highlight the drawing, you type W block on your keyboard. When you type W block, you select convert to block if it's not already ticked, then change the to millimeters, so you can use any unit you want. Then you can save the document anyhow you want to save it. So that's it. Okay guys, this is the end of this video. In our next video, we're going to be importing the general arrangement we did here in our design software ProtaStructure. So stay tuned, like, subscribe, drop your comments. If you have any questions on today's videos, feel free to drop your questions in the comment section below. And I'll see you guys next time.